This is where we left off last time, right? But we got here because we already understood momentum and change, right? Then I started talking about impulse, right? So when I started talking about impulse, you get into recalling it from Newton's second law, right? And I walked you down to be able to see how impulse and change momentum are equal to each other from Newton's second law, right? So then when we start playing around with it, we could see like how we can go back and forth, be understanding how force over time creates a change in momentum. And we did a couple problems with that. And I want us to remember this example right here, right? We did the billiards one where you're shooting the ball, the billiards go, and then they hit each other, and then you see they have a collision, right? One collides with another, they go ahead and interact, and then one goes another way. Same thing with this person over here who's catching the medicine ball while they're on skates. The person's at rest, and then they automatically catch the medicine ball, and now we got the medicine ball moving. So now we see that, right? But remember this collision, right? We're going to come to this later today. Then we have the one that makes you actually change direction that we know what's wrong. Like if we throw a ball and we hit it off a wall, it comes to a complete stop, and then it comes bouncing off, ricochets like a rebound. So we talked about that one and how you can use momentum to kind of talk about this, right? And now, when we looked at the collision or something rebounding, we looked specifically at its velocity, its acceleration, its change of momentum, and then its impulse throughout an entire system, right? And then we looked at this one right here. This one broke us down to make sure that we weren't going into formula fixation, which is basically just using the formula that you see to the right and not using our logic, right? So what we want to do right now, right, is take all of that information and let's play around with this brain teaser. Remember, I talked about formulas fixation, really understand the concepts, right? So now we want to put all these concepts together to be able to solve this problem right here. Hold on one moment, please. Sorry about that. Now let's do this brain teaser together, right? So this one, how do you want to go about it? So we have a hockey puck, right? And it's at rest. Then it encounters a force of 20 newtons for 0.2 seconds, and then that sets it into motion. And over the next 2 seconds, it encounters zero point 0.4 newtons of resistance force, right? Then finally it encounters a force of 24 newtons for zero point 0.05 seconds in the direction of motion. What is the final velocity of the puck? I'm not even gonna lie to you. I was gonna put my head in a tizzy, so I'm gonna get up, get on the board. Give me 1 second as I get on the board. Because if we take our time with this one, we should be able to map everything together, right? Y'all see that? That's fine. So first, let me just draw out. Right? You got a hockey puck. Hockey puck's like this, right? At first it's here, then all of a sudden it feels a force that sets it into motion. So now the hockey puck is moving, right? So now it's moving, right? It's over here. Then it feels a resistance force, right? So then it feels a resistance force. So now let's say we got a force that puts it in motion, then it still feels a resistance force. So if you think about it, resistance force goes and feels it on that hockey puck, right? So now it's a resistance force. But then as it goes and continues, right? There's another force that it feels in the same direction of motion as it's going across. All right. And that looks a little confusing, right? This marker's not doing too well. What?
First force was okay. First force is in this direction, second is opposite, and the third is back.
I just said resistance, right? So now let me clean it up to where it makes more sense. So let's say at first we're just at rest, right? So if I was looking at the free body diagram, I just have my puck, the normal force here, and then the force due to gravity first. This is at rest. Then we feel a force I'm moving over, right? So we still feel this, right? Now I feel what? Some type of force pushing me towards a different motion, right? So let's go there. Let's just say a force applied, right? Now, once I get here, I'm starting to feel some type of resistance force. Another force applied, coming pulling me this way. Yep. And then finally, I feel another force pulling me back this way. Now, in this scenario right here, this is not me just saying like, oh, it's just one singular force. It's just at the moment we're looking at that impulse is caused by a resistance force. So we're focusing on that, right? Because you still are moving forward, but technically that force is applied, and then it was just like maintain this motion until it just feels resistance force. So this is the force that we care about going that way. So I did kind of try to represent it in the free body diagram, right? But what does that really show, right? From now these free body diagrams, right? Like I did just have my little marker to show what's going on with the puck, right? It got a little confusing, but I wanted to at least put the free body diagrams to have the forces, right? But now what does this mean in terms of the momentum, right? So we technically have, let's say, initial momentum. Then we have a couple impulses, right? Sorry, changing momentums. No, actually, let me say this. This is an impulse, one. This is an impulse, two. This is an impulse, three, right? Three different impulses because we have forces, right? Which means we also have three different changes in momentum. This impulse causes the change in momentum. Because what we established before, impulse is equal to change in momentum. So now if we start here, we have our initial momentum. And then if we really want to, at the very end, we can have a final momentum. And from that final momentum, we can find out what they're asking for, which is the final velocity. Because we know that momentum is equal to mass times velocity. So in this final momentum, if we find the final momentum with the mass of our object being the same, we can find the final velocity. This is what we want to know. That's our unknown. Unknown final velocity. Well, what was given to us? We have a mass. And we have 1, 2, 3 sets of force and time pairs, right? So we have a force 1 and a time 1. Force 2 and a time 2. Force 3 and a time 3. So we have 3 sets of forces, 3 sets of times. I'm kind of just summarizing, right? And then from there, what do we assume? The object is at rest. So we can actually assume that the initial momentum is equal to 0, because if the object is at rest, then the velocity is equal to 0. So that's a good assumption, right? We can also assume that gravity is present throughout the entire time. What else can we assume that helps us out? Oh, not really assume, but just really the same thing. Impulse is equal to change in momentum. So now we broke it up to where we could put all these together, right, to solve this problem. That's before we even started doing anything, because it is much of kind of a brain teaser, right? But now the math should be simple to kind of just go through it. So now we already know that this initial should be equal to 0. This one's equal to 0 because it's at rest, its velocity is 0, so it has no momentum, right? Now we have an impulse. I'll switch back and forth. This first impulse, this impulse, once again, is equal to force times time. Our change in momentum is equal to mass times change of velocity, right? So now I can find this first impulse by taking force 1 and then by time 2. Time 1, sorry, right? Which will then in turn give me, what's the first one? 20 and 0.2, and then the direction is going this way. So forward, let's say forward. 20 and 0.2. What's 0.2? That's, it should be 2, forward, yes. So now that's 4. So now, because impulse is equal to change in momentum, if my impulse is 4, let's say Newton seconds or kilogram meters per second, how much is my change in momentum? Say it louder.
4.
4, yes. So this is also 4. So I calculated 4 here. Newton seconds, kilogram meters per second, same thing. Yes. So now we got 4 and 4, right? So we want to keep doing the same thing moving forward. Now I go here, my next pair is force 2 and time 2. What is my force 2?
Negative. It'd be negative.
So you got 0.4 for how long?
2 seconds.
2 seconds. And you said negative y. Good. So by saying resistance, it's actually showing that it's going in a different direction. Because the resistance force is like, I'm trying to move this way, but this wall is pushing against me. So it's pushing against the direction I'm trying to go. So the resistance force will be opposite, which means we have negative, right? Now, what does that really mean? Change in direction. So now, hold on, what's 0.4 times 2? 0.4 times 2.
Oh, no, that is 0.8.
0.8. So we got 0.8 newton seconds, right? Negative, right? So what does that mean my change in momentum is? My change in momentum should be, if my impulse was negative 0.8 newtons per second, how much is my change in momentum? Look up here. Impulse equal to change in momentum. My impulse is negative 0.8, and my change in momentum is negative 0.8. Same thing. All right, one more time. So now I get here, right? Let's do this final one. My final impulse is my force 3 times my time 3, right? What is my third force that the puck feels?
24.
24 newtons for how long?
0.05.
What's 24 times 0.05? Good. So what is my change of momentum at the very end?
So you don't, we went through final minus initial
Hold on.
momentum.
Hold on. What's my change of momentum? If I got 1.2 for my impulse, what's my change of momentum? One more time. Impulse is equal to change in momentum. Impulse is equal to change in momentum. If my impulse is 1.2, what is my change in momentum? Go from the top. We just did these, right? My first impulse was 4 newtons per second. Then my change in momentum was 4. My second impulse was minus newtons per second. And my second change of momentum was minus 0.8. The last one, if my third impulse is 1.2, right? What is my last change of momentum going to be? If impulse is equal to change in momentum, my last change of momentum should be how much? Say it louder. There we go. That's not math. It's just understanding something is equal to another thing. Now that we have this, we can actually start doing what you're talking about. Yes. Initial minus final, right? Because we need to find this final, right? So now that we need to find this final, we have to technically find out what is the momentum after each time it goes through a change, right? So we start off with our initial momentum being 0. Then we go through a momentum change of how much. I'm making sure I write everything. 4. Then we go through a momentum change of minus 0.8. Then we go to a momentum change of 1.2. So now we need to figure out what our final momentum's in, right? So let's move it over here. We need to figure out what this one is. Starting with 0, right? After I experience this momentum change of 4.4 from 0, I'm at rest, no momentum. Then all of a sudden I feel an impulse, change momentum of 4.4 kilogram meters per second. What will my final momentum be after that? If I go from 0 and I feel this impulse of 4.4, what will my momentum be after that? Because remember, change of momentum also equals the final minus the initial momentum. So in this case, right, let's say my initial momentum is 0, and my change in momentum is 4.4. My initial momentum is 0, my change in momentum is 4.4. Technically, what would my final momentum be? If I start at rest, I'm not moving, and then somebody pushes me like this puck, and I feel 4.4 kilogram meters per second. What would my momentum be? Not moving, and I get pushed forward. Really, the puck gets pushed forward. Anybody online?
It's just letting me log on, so I don't know how long you guys been on here.
All I'm asking, can you see the board?
Yeah.
If I have a momentum that's initially 0, and then it pushes me forward 4.4. Sorry, I push the puck forward with a momentum, change the momentum of 4.4. I'm starting off with 0. The change is 4.4. The final should be equal to what?
Somebody said on the chat.
Yes, 4.4. Oh, sorry, I didn't see the chat. So that means that the final here is 4.4. Let's say final 1, or just say momentum 1. Now my momentum is 4.4, right? Because I was just adding this to this. Now let's do the same thing, right? Let's add this next momentum here. So let me just put like an add, right? So now let's do this one. So this one is done. Let's go to this one here. So now I'm gonna go here, and it says we have a momentum change, right? But what is this momentum change? Negative 0.8. So I have initial momentum now of 4.4 because this becomes my initial now. And now I change it by negative 0.8. Technically, I would add this 4.4 over here and do some math, but just think logically. My momentum is 4.4, and then it changes by negative 0.8. What is my momentum now? You could do the algebra to kind of figure it out, but just think about it logically. It was 4.4, and it changes by negative 0.8. So what should it be now? .4 changes by negative 0.8. Close. Actually, I don't know why I said close. That was right. Yes. Right.
Oh, I think you put 4.4. I think we initially got 4.
I keep putting 4.4. You're right. I don't know why. 4. 4, 4. So now this one is 4, 3.2. Yes. So it's 4, 3.2. So now my momentum, P2, let's say, is equal to 3.2. Now let's do one more momentum change, right? So now this one is done. So now let's go here, right? So now I change momentum one more time by 1.2, right? That's what we calculated. So now what would my final momentum be? 3.2, and now I have a momentum of 1.2. That changes. It changes by 1.2. I had messed up. It was supposed to be 4 minus 0.8. So then it's 3.2. But now I have 3.2 and I change it by 1.2, positive 1.2. So now I have 3.2, change it by positive 1.2.
Someone put something in the chat.
Yes, 1.2. And we started off now at 3.2. So 3.2 and 1.2. So we have 3.2 and change by 1.2. Three point two, and then we change by 1.2. Anybody? My final, I'm trying to find because my initial is 3.2, but my change is a positive 1.2. Technically, I just add this over if I want to do math, but logically, let's think. I'm going one way, and then I change positively in that same direction. I had an impulse, a force going that way. And then once I add it, so I say increase or decrease? Increase or decrease depends on the direction. This last one, if we set a direction, it says in the direction of the motion that was already going. So it's not a resistance force. And then also by the change in momentum, it's positive. So technically it should be an increase. So now I'm looking at the chart. So we add, yes. So if we add 3.2 and 1.2 to where I get what? There we go, 4.4. So now we got a final momentum of 4.4. This is what we was looking for, right? Our final momentum of 4.4, because now we could find the final velocity because all we have to do now is do 4.4 kilogram meters per second times the mass, which was the mass, 0.1 kilograms. And then now we can find this final velocity. So if I divide 4.4 by 0.1, I get what?
$44.
44 meters per second equals the final velocity. All right. This board looks like a lot. So let's start from the top, right? I drew my diagram to see what was going on, right? So now let me see my diagram of what's going on, right? I said, okay, how is the puck moving through? Now let me understand how the puck is moving through. I was able to draw my free body diagrams to make sure I just at least got the forces going in the right direction because we got all these forces. Now when we get all these forces, right? I want to sit here and I want to put it together because now I need to figure out with these impulses, how is that going to affect my change in momentum? Because I need to figure out what my final velocity is, which means I need to find out my final momentum. So I start taking these impulses and making them to where now I can find out my change in momentum. Now I already knew it was at rest, so I have my initial momentum. Now I just need my final momentum at the very end. And I use these changes to see how it changes over time. So once we figure out the change of momentum, all we do is just see how they change over time. The only one that was negative was this resistance force. And we identified that with the direction and by the negative. Everything else is positive, so we just keep adding positive. So we basically just add all these changes of momentum together with that initial to see how it goes at the very end to where now we get this 4.4. Now we got our final 4.4 change of momentum. Sorry, final momentum was 4.4. And all we got to do is divide that by the original mass. The brain teaser part is really just being able to just see you just doing the same thing over and over and over again, but understanding the concepts. Impulse equals change of momentum. We also have to understand the concept of a resistance force versus the acting force of which one's going against the grain. So now we know the direction. And then once we go from there, we pretty much just do simple math and add it together. So this one took a little bit of time, but honestly, it wasn't that difficult. Any questions? All right, give me 1 second. All right, give me 1 second. Let me just stop the recording.